So I'm at Mr. Chippy's bench with the Duette CB40 hand portable, which is the DNT HF13 40 half watt 40 channel handheld from 1981. I never really liked them, but they do work reasonably well. I don't think they're the most reliable beast in the world. I don't think they're the most well made things. Wishy-washy squelch. Well, what we got? On-off volume and squelch, external error, which is a 3.5mm jack, charges on a 2.5mm, so if you use rechargeables, of course, that's what happens. It goes in there. 8 AA's go in there. It does have a meter on it, which is quite rare for a handheld, and it has receive on the meter, which is even rarer, because most of the time if you have a meter on a handheld, it's going to be just relative RF output, which is a glorified battery test meter. So they have a nice long telescopic error. I can't really show you that on camera. I'm doing this at Mr. Chippy's bench because I've now finished the videos for the transmit and the receive and the on the air test, and then when I came to start editing the video to upload it to YouTube, I discovered that there's no part of the video is missing, so there we go. We've had to do it again in here, so we're doing it to the camcorder. So we'll carry on now, and the next part of the video you'll see I've taken the radio apart and we're about to do the transmit side of the video. So having opened up the radio, we find a clean battery compartment for 8 AA's, which is of the clippable type and easily replaceable. You sometimes see these on eBay with the battery holder missing, and some Wally has connected the PP3 9V battery and they think that that's how it works. So uses an LC7317 synthesizer, and according to what I've worked out from the circuit diagram, we've got receive, receive, receive detector, and VCO receive, VCO transmit. I think it's that. That could be detector, thinking about it, and then that'll be VCO transmit, and then the rest are transmit. And the bottom one there is deviation, and then because it has an S meter, you never know, there may be some adjustments for that. It certainly says there are. So there's your little S meter, which is quite unusual on a handheld, and a nicely long telescopic aerial. Now I think these work quite well, and Mr. Chippy, if we can get this to work, we'll be driving away 6 miles, and I don't know whether we've achieved that before, but we'll see. So I'm going to connect it up to the test equipment. We've got an external power socket there. We can plug an external antenna in. What we can't do is plug an earphone in, so when I come to do the receive, it's going to be quite a pain in connecting to the loudspeaker. So it's going to have the board out. That's going to be an absolute pain. Right, we'll pause the video and I'll get things connected up. Okay, so I've made up a lead, which is 3.5mm to PL259, so that's the way I've had to do it. I didn't have an adapter here, and it seemed to be quite expensive to order, so that's how we're doing it. I'm competing with the radio. It's gone. Our background music system's gone over to radio as it's coming up on the hour, so I'm just competing with that. But the receive VCO is L6, which is that one, and the transmit VCO I seem to think is L74, which is that one. So the transmit starts with L7, which is that one. So it's going to be 7, 13, 12, 10, 9 and 8. That's what I'm expecting. So we'll go into transmit, and of course without an external microphone it's a bit of a faff. And straight away we have got 120 milliwatts. I'll just switch over to the camera. So we're going to transmit, and we'll start with that first adjustment. So it's interesting to note that this, I will just mention, I'm not hearing anything on its loudspeakers. When we get to receive, I think this has a fault, and I hope that's repairable. So as you gathered, that was somebody at the door, and it goes over our 22 loudspeakers around the premises. So having dealt with that, we'll back to transmit. Now, as you know, these are interactive, so we'll run through those again. I do wish I'd got an adapter rather than having to make this little lead up, because the fact it's got a back-to-back SO239, which is called a PL2580 for those who don't know, in the lead, is lossy. So although we're doing about 200 milliwatts, it probably is half a watt out of the radio. You see, this is the problem. I don't think this is faulty, but we're only getting the 200 milliwatts. I'm going to be naughty. I'm just going to knock the power supply up. We should be on 12 volts. And it just makes me wonder. I'll just put this to 13.2 and see what power we get at that level. And the answer is 250 milliwatts. So I think we're about right, to be honest. So although it's reading half what it says on the tin, we're going to have incurred losses in this lead arrangement. So, and who's to say that they do half a watt anyway? Let's look at the spec. Yeah, it says 500 milliwatts. Right, well, we'll move on to the deviation. That's disappointing, really, but we'll move on to the deviation. So we'll put the oscillator under the microphone. going to transmit. And we've got 2.9, it's a bit over the top. And the adjustment for that is the preset just there, which is resistor 46. I'll just pop that down a fraction. And I'll just do a little whistle test in the general direction. Wallow. Yep, that's 2.5. That's great. It's probably been fiddled with before, you know. Now, is it on frequency? I'll just move the camera so you can see the frequency counter. So, the adjustment for the master oscillator, the 10.24, is the little preset capacitor there. Just get my yellow trimming tool. So we're looking at that one there, and I'm going to transmit. So on channel 20 we should be looking at 27.79125. Look at that. That's absolutely fine. I'm just going to touch it up that fraction because it doesn't really need it. I'm about to go the wrong way. Wow. Doesn't get much better than that. Now then, the TX meter. That's going to be fun. Now under this piece of, I'm going to say cardboard, but it's a fibre board, which is supposed to be screwed down. We'll have to kind of reinforce that and take the screws out and put them back in again. You've kind of got the transmitted audio board here, and you've got the meter driver. So I don't know which one of those is going to be the one, because it's not labelled. Oh, it is. Oh, I tell a lie. It is labelled, because we've got this subboard 31, and I made a note that that's 37. I can hardly read it. So the left hand one's 37, the right hand one is 34. So the left hand one is the transmit meter. So what we're going to try and do, this is going to be fun, is hold that in such a way and put the tool in underneath that when I press transmit, so what we want is that to read why would you have a meter that goes to 3? Or is this milliwatts? It will be, won't? Yeah, so if we set it to 250, we're there. Because you want it to deflect. It means nothing, doesn't it, that? So there we go. That is the transmit set up for what it's worth on the Duette CB40, also known as the DNT HF13/40. So we're going to move on to the receive, and I have a suspicious feeling that this is faulty. So welcome to the receive side of the Duette CB40, also known as the DNT HF13/40. We're on the receive side, and I've got a switch on thumb and I have no receive. So that is rather annoying. So we're going to start fault finding. I've got a signal on a signal generator. The signal meter on the radio is reading nothing. I'm at full pelt on the signal generator, so one would expect that to be reading on the meter. So I don't think it's just an audio problem. I wonder if there's a voltage rail down. We have the audio amplifier IC here, and what I'm going to do is just look at the circuit diagram and just see which pin the audio comes in on. It goes in on pin 3. So basically, if I put my finger on this screwdriver on pin 3, we have absolutely nothing. We should be getting a buzz. So the fact that there's a switch on thumb tells us that the loudspeaker's doing something. Let's just turn it off and I'll put this to the microphone. There we go. So it's not that the speaker's open circuit, and it's going to be quite frustrating to set up with the test equipment because the speaker has got no socket for an earphone or external speaker, so it's going to mean having to pop the board out. I dread to think, well, how entailed that is, but I want this job to be right. So we're going to have to do some fault finding. So why is there no audio amplifier running? It's possible this has been reverse polarityed, because one thing I will tell you is external socket, which is a 2.1mm normal type of power connector, it's negative center, it's not positive center. So it's easy for someone to apply positive center and perhaps do a lot of damage to the radio. So let's see if we've got a power rail, and we should have got on pin 6 a rail voltage. So let's have a look. I'll put the meter on. See what we've got. Well, we've got 12 volts on pin 6. So you would think that with 12 volts on pin 6, there should be no reason why the audio amplifier doesn't produce something when I touch pin 3, which I did before. Let's try it with the meter probe. Oh yeah, we can hear something with the meter probe. So the amplifier is running. Now if there's no FM hiss, it makes me wonder if the MC3357 IC, which is the kind of receiver in a chip arrangement up here, makes me wonder whether that's faulty. So let's see whether we can hear anything. So I'm touching pin 9 of the MC3357 with my probe, and I can still hear that bit from the speaker. So that tells me that there's continuity between there and the amplifier. So it's it is pointing its way really to the MC3357 being faulty. but I'm just seeing where it gets its receive signal from for the meter. And it seems to get it from pin 15. No, it doesn't. That's earth. It gets it from the output of transistor 3 there, by the looks of things. So if the IC was faulty, then it still wouldn't receive a signal on the meter. So that's my logic. So I think we're going to have to go for that. So we'll stop the video. Right, we're not quite out of the problems with this because there is a dry joint. Mr. Chippy's just changed the MC3357 and we now have receivers you can hear. That's receiving at 1 microvolt. You know, so that's kind of good. Again, I'm competing with the radio, and I found that capacitor 29, the output of the audio IC goes through capacitor 29 to the speaker. Capacitor 29 is the capacitor there, which is the capacitor there. So I'm going to treat this with kid gloves or it's going to go off. So I can just put the inner of my 3.5mm jack plug onto that capacitor, and now we're hooked up to the test gear. And I thought that was going to be a real pain because of getting to the speaker. So we'll start with L2, which I think is that one. And then we'll look at L3. L4 is it? Yeah. And that's it. The other one's the detector, L5. And they've neatly covered that. So I'm just going to, oh, we've gone off. Oh, we're on again. We'll put a big signal on that, 100 microvolts. And I'll just to get maximum on the oscilloscope. And the dry joints around here, so it's not easy to do this. These are double-sided boards, and sometimes if it's the top side that has failed. No, we're going to have to do that dry joint before. Well, I'm going to complete the alignment with the board kind of dangling out of the set. We seem to have cured the dry joint, so I then put it back and it didn't work at all, so it's a bit of a faff. So we'll go back to the detector. So I'll just go with that 3.5mm jack plug on the capacitor. We're recording. Now, we were trying to set the detector last time. I'll take that light off and then hopefully we can see the oscilloscope. There we are, that is peak with an S9 signal. I'll just go through this a final time. I'll put the light back on. They are interactive with each other, as I keep saying. You have to go backwards and forwards with them. And that's about as good as we're going to get. So, let's see what that is. Uh, 0.6, 0.8, 0.7, 0.6, 0.5, 4. Now we'll set the squelch. In fact, I'll turn the volume down a bit. So we'll turn the signal generator off, set the squelch, bring the signal generator back on, 1 microvolt. Set the squelch to full, 3 microvolts. Really weak, wishy-washy squelch. It's not adjustable. Not a good feature on this type of radio, but these are hand portable, and you know it's not really for base station use, so we'll give it a bit of leeway on that. Now that just leaves the S meter to set up. So I'll just pop the camera back off. There we go. And I've still got this radio in bits. Let's try. I'll put an S9 signal on, and what we'll try and do, it will be that preset, which is resistor 34, and let's see where my meter is at the moment. Well, I've got S6 on there, so I'm going to try and swizzle this round upside down, put the tool in, and there we have S9. So there we are. All I've got to manage to do is put it back together and for it to still work. So that concludes the receive side of the Duette CB40, also known as the DNT HF13/40. So we're going to do an on the air test with it, and thank you for watching.